Okay, good afternoon to you once again, and we are back to the lecture 5 of basic algebra. And here we have learned the basic rudiment, the basic ideas that you need to start with your mathematics. And I think so far you can do some maths for now. And when there is a problem, you know where to start from. And all the maths we have been going through, they are the basics. And the particular name for that one is a linear equation in one variable. One variable. In other words, when you are solving a problem where there's only one thing you don't know, like there's one unknown thing in it, you should have a way about it. Having gone through lecture 1 of the basic algebra up to lecture 4, you should have equipped yourself with some skills needed for mastery. So now, if you have 8r minus 5 equals to, say, 27, for example, you should have an idea where to start from. We ended by saying that you need to group like terms, and by now you know what we mean by like terms. So now, when you know that, then you know which of the terms are alike. You should know that 5 and 27 should be alike. And we've gone through that from lecture 3 to 4. We have gone through that. So knowing this, I now know that I have to undo this one first and come to 8r equals to 27 plus 5. And I know by now, you know that this is how it's supposed to go. And a subtracting number go over the equal to sign to go and add. Now, after doing the effect of subtraction, you will now be left with the idea that two numbers multiply themselves to give you an answer. The understanding we have established is that one of the numbers equals the answer divided by the other multiplier. So we come to this place. So from here, you now say if 8 should divide 32, you get a 4. And so the number that R is hiding from us is a 4. Beautiful. So let's say you have another thing like maybe 43 minus 9/2m equals to 70. So when you have a situation like this, you know what to do. We have established that every term, whatever sign you have to the left of it, that sign tells whether it is a positive or a negative thing. Now that we have nothing written before the 42, you can take it as a positive number. And with this, we know that all these are negative 9/2m. So if we want to send the 43 to go and group them with the 17, then it is a positive number crossing over to the other side, and that make it negative. So you maintain the negative 9 attached to this very term, whilst you go over there to say this is 17, the host must be where it is, before the guest come over to the other side. So if you are a plus and you come there, you tend to be a minus. Then after getting the answer you will get for that, you will realize that when you are deducting this, you will get that is 6, and then this is 3 minus 1 is 2, so negative 9 over 2m equals to negative, because this one is smaller than this, so you will get a negative, so negative 26 will come up. Negative 26. So now that you are here, it is time to undo the numbers one after the other. But you realize that the very 2m is actually dividing. And if you understand what we learned, even from the basic algebra lecture 1, if two numbers divide to give you an answer, one of the numbers is the the number at the top, called the dividend, is equal to the answer times the divisor. So I could actually send all these to go and multiply the other side as in obeisance to, or in accordance with the rule. So what should be done is negative 9 is actually equals to negative 26 times 2m. That's what's supposed to go. Then once we reach here, we will now get negative 9 equal to a multiplication of this negative 52m. In other words, 26 times 2, 52. Now we want to make m, we want to get m, and you understand that if two things multiply to give you an answer, one of the things will be the answer divided by the other multiplier. It's like the whole thing was written backward, but the rules remain the same. If the two items multiplying are even at this side, so and the answer is at this side, the rule still remains that if two things multiply to give you an answer, one of the numbers is the answer divided by the other multiplier. So we come and get to say this is negative 9 over negative 52 will give us an m. Will give us an m. At this level, we realize that nothing can cancel 9 and 52. And as such, but negative divided by negative actually cancels out. So we know that our m equal to the fraction 9 over 52. If you want the answer to be a fraction, leave it like this. Other than that, you can make it a decimal and get a decimal version. But at this point, you know how to get a decimal out of the system. So if you can work maths to this level, having followed our videos up to now, then it means you are built on a very good stage, a very good ability to be able to transcend into the higher realm of mathematical endeavors, mathematical manipulations. Very good. Now, what more is there to this maths? Maybe the only thing that I did not include here is that if in the course of working this math, there is a bracket, you are given a bracket and things are written inside the bracket, the first thing you should do is what we call open the bracket. Yes, to make your work easy, open the bracket. Then, what do you mean by open the bracket? Let me give you a typical example. Maybe you have something like 3r. Now I've used r already. Maybe let me change it. 3 k minus 5 into bracket 2k plus 7 then equals to, let's say, 35, for example. If you have a bracket inside your work, you must open up the bracket. In other words, undo the bracket effect. With issue regarding a bracket and something hanging outside it, the idea is that whatever is outside the bracket multiplies everything in the bracket one after the other. So this 5 comes to multiply the 2k, after which the 5 now comes to multiply the 7. So if you have that clearly, that means it will be 3k minus 2, 5, 10. And you attach the k, and then after that 2 times 7. Don't forget it's negative 5. Negative 5 multiplying the 7. So it's going to be negative 35. Negative 35 equals to this 35 that is there originally. It is after you have done away with the bracket, that is where you proceed to use the idea group like terms. So that's the stage. If there is a bracket in the way, make sure it is undone. Then you know the things that are like terms, all those things that are having k attachment, they are alike. And those that do not have k are unlike. So these and these are alike, and these and these are also alike. So you group like terms, and by our rule, if you remember, if you are bringing like terms together and there is no equal to within the gap, you group them raw like that. But if between the two where the like terms are, there is an equal to separation, then a minus something will go over there and go and plus. So between this and this is just 3k minus 10k. Like if they give you 3 oranges minus 10 oranges, yeah, I mean that will be negative. Yeah. So that will give negative 7k. That's what the result. Negative 7. Now, between these 35 and this, there is this particular sign, and that's what it says. So if this minus 35 is going there, it's going to tend to plus 35. So that becomes 35, which is this very 35, and this one will be plus 35. That's what happened. So when you get there, you get negative 7k equals to 70. 70. And if you remember what we learned, if two numbers multiply themselves to equal to an answer, one of the numbers is the answer divided by the other multiplier. The idea remains constant, unchanging. So whatever number k is trying to hide is actually 70 divided by negative 7. And if you calculator, or if you can actually tell that this divide this will give negative 10, then our k number is actually negative 10 concluded. Concluded. So the attachment I'm adding to the equation is that if you have a bracket in your work, make sure you undo the bracket, and you undo a bracket whenever you use whatever is outside the bracket to multiply everything in the bracket one after the other. One after the other. Once that is done, the bracket will be no more in the work. Good. Then the last thing I would like to talk about is that whenever there is fractions in the work, whenever there is fraction in your work, what do? The best way we found out the work mass that has got fraction in the work is that look for a number which all the denominators of the fraction can divide, the list of them. And it is normally called the LCM. LCM meaning the least common multiple. The least common multiple of all the denominators of the fractions. Let me give a typical example, and that will make it clear. Imagine that you have this mass to solve, like say 3 over 4 plus have okay, let me just make it plus x over 2 minus 1 whole number 1 over 3 equals to x over 5 plus the same 3 over 8. So maybe you have this kind of mass that you want to solve. What do you do? First of all, if there is a fraction in the work that is a mixed fraction like this one, change it to an improper fraction, so that all the fractions will be improper or proper fraction throughout. That's the first thing you should think about. So let me go to that level. So this implies that I'll have 3 over 4 plus x over 2. Then at this particular level, when there is a mixed fraction, the denominator multiplies the whole number part. Then you add the numerator to it. So 3, 1, 3 plus 1. 3 times 1 is 3. So 3 plus 1 is actually 4. So that becomes 4 over 3 for this part. So the whole fraction is actually 4 over 3. Don't forget that 3 will divide for one whole number and there will be remainder 1 over 3. That's why it can turn this way anytime. Now, when you are at this level, this is what you should do. All the denominators of the fractions, look for the number that is the least among all the numbers that all of them can divide at the same time. That is called the LCM. The LCM. Somebody will say that it's fine difficult to find the LCM, but I would like to give you some short way to find LCM. If they tell you to find LCM of two numbers, like say, find the LCM of 4 and 6. You want to find their LCM. This is what you should do. First thing, look for the number that can divide these two numbers without leaving you a remainder. They can divide, the number can divide 4, no remainder. It can divide 6, also no remainder. And if you look through, you will see that that number will be 2. Right? Good. After you've got that number, put it aside. Your LCM will be like this. The LCM will be multiply the two of them. 4 times 6. After that, divide by that very number you found which can divide two of them without remainder. Once you got that, you've actually gotten the LCM, and this 4 times 6 is actually 24, and 24 divided by 2 is a 12. And you can bet that 12 is the least of the numbers which both 4 and 6 can divide them without actually leaving you a remainder. So this is the smartest or the shortest way to find an LCM. Take the two numbers involved, look for the smallest number that can divide each of them without leaving a remainder, and you get it and write it somewhere. After that, multiply the two numbers that you are asked to find the LCM of, and divide by that very number which is the common factor, the highest common factor. This number is called the highest common factor of them. So when I get 4 times 6 and I divide by 2, I get 12, and 12 is the LCM of 4 and 6. So this is the smartest way. So when you tell me to find the LCM of two numbers, I just look for, so maybe they say find the LCM of maybe 6. Okay, let me see, like 8 and let's see 8 and let's say 12, like this. If I want to find the LCM of them, first thing, what is the biggest number that can divide 8 without leaving a remainder, and that same number can divide 12 also without leaving a remainder? When I check through, I think that 4 will be that very number. So I put it somewhere. That is the highest common factor. That number is called the highest common factor. Okay, so your LCM will be multiply the 8 and the 12. Whatever number you get, divide by the highest common factor, 4. And once you do that, and even with cancellation, 4 here, 1, 4 here, 2, 2 times this is 24. 24 is that number, which both 8 and 12 can divide them easily without remainder. That's the LCM of them. Fine. So when you have a question like this to solve, take all the numbers involved. 4, 2, 3, 5, and 8. The denominators of all the fraction. Find the LCM of all of them. If I find the LCM of numbers like this, you can use the idea and it still work. But you can use other ideas to that work. You can find LCM of 2 of them at a time. You can find LCM of this and this. Then after that, you use that on you come and find LCM of that, LCM and this. And you come and find LCM between the LCM of these 3 and the third one and the fourth one, and do so until all the numbers are done. You can do that. For example, if I want to find LCM of 4 and 2 is 4. Now, the reason is that the number that can divide both 4 and 2, the highest common factor is actually 2. So if I multiply 4 times 2 and divide by 2, I'll end up getting 4 back. So the LCM of this and this is 4. Okay, what is the LCM of 4 and this? The LCM of 4 and the 3. Between 4 and 3, the only number that can divide them without leaving remainder is single one. So you just multiply them straightforward, because any number divided by 1 is the number itself. So 4 times 3 is 12, and 12 divided by 1 is still 12. So the LCM between this is 12. You can go and find LCM between this and this. This and this to 12 and 5, the only number that can divide them without remainder is still 1. So the LCM is just 12 times 5, which is 60. So it is 60. Now, you find LCM between 60 and 8. How do you find LCM between 60 and 8? Look for the biggest number that can divide 60, no remainder. You can divide 8, also no remainder. And if you check, you realize that the number will be like 4. Okay. When 4 divides 60, it will be 15. And 4 can divide 8 also 2. Yeah. So if you multiply 60 times 2, times 8, sorry, and divide by that 4, you will be getting the answer. If you cancel this here, this 2 and 2 times 60 is 120 will be the LCM. So if the LCM of all these numbers is 120, is 120. 120 is the smallest number where 4 can divide without remainder, 2 can divide without remainder, 3 can divide without remainder, 5 can divide without remainder, and 8 can also divide without remainder. If you get that number, to help you make your work easy, multiply every single term by that LCM. What will happen? Let's see what will happen. Now we know the LCM is actually 120. 3 over 4 times 120 plus x over 2 times 120 minus 4 over 3 times 120 equals x over 5 times 120 and 3 over 8 times 122. And when you do that, because this number can divide this, and this is the number that all of them can divide, that is why it will be 4 here, 1. And when you are dividing like this, if you don't have calculator, what you should do is that you should use the 4 you start dividing from the front. 4 cannot divide 1, so when I attach the 2, it becomes 12. But 4 can divide 12, 3. No remainder. And 4 can divide 0, 0. So you must attach the 0. In other words, 4 will divide 120 30 times. Okay. The same apply here. This divide here. Since 2 cannot divide 1, I bring this one 12. 2 can divide 12, 6. And 2 can divide this 0. So that's 60. And the same apply here. 3 here. 1, 3 into 12 is 4. So 3 divided 0 is 40. And this 1, 2, this the same thing can apply here. 5 can divide 12 2 times. 2 times. but there will be remainder. Remainder 2. That remainder 2, when you attach the 0 to it, it becomes 20. And the 5 can divide that 20 4 times. So, in fact, the answer is 24. It's 24. So, if you do 24 times 5, you'll get 120. Yeah. The same apply here. 8 here, 1. But 8 divide 12 is only 1/8 that you can get from 12. There will be a remainder of 4. That 4, when I attach the 0, that makes it 40. And if 8 should divide 40, 8 5 40. 8 5 40. So that's it. Now, after that, you use this numerator to multiply these cancellations you've made throughout. 3 times 30 is like 339, you know, and add the 0 is 90. And 60 times x is 60x. And then 4 times 40, you just do 4 times 4 and you get 16. And you add the 0, and 160 will be that, equal to 24x. And this time, this, if you actually do it, you get 45. Yeah. Now, what happened is that all the fractions have disappeared from the work. Immediately, you multiply by the LCM. So, the advantage is that once you get the LCM of all the denominators and you use it to multiply each term, the result will be that you are going to see a mass where there will be no fraction in the work again. From here, we have learned what to do. Group like terms. Then you proceed. 60x and 24x are alike because they have x attachment. Meanwhile, the 90, the 160 and 45, they are also alike differently. So we group them like that. And remember the rule. If this sign is between the two things you are bringing together, then one will change the sign when it approaches the neighbor. But if this sign is not there, then we don't change any sign. We add them or subtract them raw like that. Between the 60 and the 24, there is equal to separating them. So this one, when it's coming here, to tend to negative. So it will be 60x minus 24x. That's what will happen there. But if you look at this, you can send all of them at once anyway. The 45 is here already. If the 90 is coming, don't forget this positive 90. Once you don't see any sign here, the thing is automatically positive. So if the positive go, there will be negative 90. And the negative 160, when it go, there become positive 160. Like that. So at this level, you just get the total of this. And this will be 36, right? 36x. And when you get the total of that, what do you think you get? That will be, even if you take 90 from 160, you are going to get your 70 added to this, and you are going to get 115. Then at this point, you now divide and you get the answer, because we have learned that whenever two things multiply to give you an answer, one of the numbers is the answer divided by the other multiplier. So from lecture 1 of the basic algebra, we've established that. So this 115 over 36 over 36. If it is possible to cancel anything, you will do it. But if it is not possible, you can just tell how many of these will enter here and then the remainder. So if I check that, we are going to get, if 2 of these enter there, it will be 72, right? 72. If I add another 36, that will be 108, right? Yes, 108. So I can get 3 whole number. That means 36 can enter there. 3 whole number. Then the 3 of them will give 108. So you are going to be left with 7. So that will be 7 over 36, and that ends your calculation. That ends your calculation. So the whole idea is this. If you have a fraction in your work, to undo the fraction, find the LCM of all the denominators of the fractions in the work. Once you've done that, use that very LCM to multiply every single term in the work. And immediately you do that, all the fractions will disappear from the work. And the only thing that will be left is to group like terms, and then you will solve it easily from there. If there is a bracket in the work, I have just said, you undo the bracket by using whatever is outside the bracket to multiply everything one after the other inside the bracket. So if you have followed up to this level, you realize that you have acquired the basic skills needed for you to do well in this subject. Now, that said, we want to proceed to other aspect of knowledge. Time running over. How many minutes? Okay. So we have polished the end of this particular lecture for you to know how to basically handle any mass of this kind where only one variable is in the work, and it is called linear equation in one variable. That is the official name of this particular mass. And by now, we are going to close our lecture 5 here and proceed, but the idea of the basic algebra is not done yet. Thank you very much for watching, and then we'll see you in the next lecture.